Climate change and avoiding too much global warming is a key challenge in our society. Our atmosphere is only 0.5% of the Earth's radius, so we need to protect that. Geological storage of CO2 is part of the solution. With carbon capture and storage technology, we take CO2 from industrial activities and inject it into deep geological rock formations, where it will migrate according to complex physical models. There is much uncertainty in these processes, so how can we ensure that the CO2 is safely stored? Here at NTNU in Norway, we're focusing on the development of geophysical monitoring methods. Imagine this plume of CO2 forming deep underground. So you're injecting CO2 here and the plume is evolving. You can sort of see this using seismic surveying because the elastic properties of the CO2 are different from the water it replaces. So the conventional way of doing this is to have a vessel with a source towing receivers on a streamer. And then through seismic imaging, one can see the difference in elastic properties. One could also have receivers on the seabed, or one could have fiber optic cables and then use distributed acoustic sensing.
We can show how geophysical monitoring is used for CO2 stores using the case of Sleipner. At Sleipner, the CO2 has been stored 1 kilometer underneath the North Sea and stored there for 30 years. Here you can see our most recent reconstruction of the CO2 plume at Sleipner. We have used full waveform inversion, processed to high frequencies, to reveal details about how the CO2 moves through the different layers of the storm. We also conduct geophysical experiments in the laboratory using an acoustic ray and a 3D printed version of Sleipner to understand how geophysical monitoring works.
By using receiver nodes or distributed acoustic sensing, one can also listen to earthquakes in the storage reservoirs. Most earthquakes are natural according to tectonics, but the increased pressure from CO2 injection could also induce small earth tremors. At the Center for Geophysical Forecasting at NTNU, we're building historical earthquake maps. This can help us understand the natural activity before CO2 was injected into the subsurface. What if CO2 leaks into the atmosphere? Then we can use satellites to monitor CO2 emissions, and in Iceland we've been able to quantify the CO2 emissions from volcanic activity.
Right now we're looking at satellites measurements over the volcanic eruption of Fagradalsfjall, located in Iceland, and we're using this data to understand natural CO2 emissions.
As the energy transition gains momentum, our society will need multiple technologies: carbon capture and storage, renewable energy such as offshore wind farms. We are developing the monitoring tools we need for a green energy transition.